Hi, everybody. It's producer Susie with you here today on a Monday. And let's see, double check the date. It is Monday, February 10th, and we are here to put some science in your brain. So, welcome to the Daily Space. We hope you are very happy to be here, and hopefully, you are having a wonderful Monday where you are. It's cold and rainy here in Atlanta, but I'm inside, so that's fine. So, I will get started reading you some news here. And I have my script on my iPad once again, so apologies for me not looking up all the time. All right. One of the best things about covering astronomy news is seeing how ideas change year after year. When Dr. Pamela first started astronomy, we were still very uncomfortable with the ideas that stars might be merging into something new. She remembers people struggling with the idea that unusual blue stars and globular clusters, called blue stragglers. Yeah, try to say globular clusters and blue stragglers on a Monday morning without coffee, and you won't do well either. Blue stragglers might be merged stars that appear younger than they were actually due to the merger event. So the fact that they'd smushed together means it was very hard to tell their actual age. So over the decades, more and more observed stars and events have been attributed to mergers. One of the main explanations for our coronae borealis stars is the merger of two white dwarfs that we see gravitational waves coming from, merging black holes, merging neutron stars, and every combination in between. These classes of observations are making it clear that mergers aren't entirely unusual. And as we look to try to explain oddball systems, we need to consider stellar mergers as a possible explanation. So we recently covered supernova SN 2006 GY here on Daily Space. This was an oddball explosion that was one of the brightest supernovae ever recorded, but it appeared to be a type 1A supernova driven by an exploding white dwarf star. In trying to explain this weird system, astronomers figured out that a white dwarf had fallen into a giant star and exploded while shredding the giant star's atmosphere. Today we get word that weird star HD 101584 can also be explained as a stellar merger. First remarked on in 1995, this particular supergiant is surrounded by layers of unusual material. The system was recently studied at the Atacama Large Millimeter Array. And I'm not exactly sure when to change my slide, I'm realizing. It was recently studied at the Atacama Large Millimeter Array, and with its added detail, astronomers led by Hans Olafsson were able to resolve odd jets streaming from this evolved star. Jets aren't normal for evolved stars. And the best way they found to explain this system is the giant star consuming a nearby companion as it evolved. So this star started out not too unlike our own sun. And, like our own sun will do one day, it evolved, it expanded out to have a radius roughly the size of Mars' orbit. While our sun will only eat planets, this HD 101584 had a small star snuggled up to it in a tight orbit. And as it expanded, it ate this small star. Now this did not go well for anyone involved. And my son's coming home, so my dog is barking. According to the press release, this caused the red giant to go absolutely berserk. It erupted prematurely, explosively ejected gas layers, and is currently in the process of exposing its naked core. It was total carnage, leaving behind a gorgeous complex nebula of star guts, carved out by the smaller star's death spiral. We couldn't find a copy of the ALMA data to share, but one of the cool things is that they found this system has polar outflows and a figure 8 of dust and gas. This system shows that spectacular beauty can come out of horrible destruction, one of Dr. Pamela's favorite things. And it shows that while space is mostly empty, stars can find each other and merge in explosive ways. Thank you, Frecked Chemist, for subscribing. We appreciate that. So as we build more and better telescopes, our ability to find and understand these kinds of unusual systems will just get better. Not all of these telescopes will take beautiful images, though, and the initial images sent back from the European CHEOPS space telescope will leave you wondering if the telescope works right, until you know how the telescope is being used. In mid-December, CHEOPS launched on a mission to determine the size of extrasolar planets. This can only be done by very precisely measuring how long it takes for a planet to start passing in front of a star, and then be fully in front of a star. This kind of detailed measurement of brightness is extremely difficult, and it turns out even more difficult if your telescope has stars focused perfectly into tiny little pinpricks of light. For this reason, astronomers, including our own Dr. Pamela, will sometimes unfocus the telescope to spread the light out over more pixels. CHEOPS is designed to defocus stars around dozens and dozens of pixels. The odd pattern that can be seen in its images reflects the optics of this Ritchie-Chrétien-style telescope, which has a mirror in front of the telescope that is suspended from 3 arms. You can see an example image on our website or right here. That's why this image is not spectacular, but it's pretty cool when you realize what it's doing. So, yeah, sometimes we have to slightly unfocus our telescope so we can see things a little bit better. I think we do that with our eyes sometimes too. Sometimes you just kind of unfocus your eyes to be able to see things better. All right. The final story of the day comes from a spacecraft. In this case, we look back at data from the Rosetta mission. One of the questions that has puzzled comet scientists is why did comet CG67P look red with a blue coma when it was far from the sun, and then look blue with a red coma when it was near the sun? Well, as is so often the case, dust is to blame. I hate dust. You probably do too. When the comet is cold and far from the sun, the dust settles to the surface, making the dusty surface appear redder. When the comet is near the sun, the surface gets heated up and sublimates from solid to gas, with the sublimated ice carrying the dust away from the surface. This leads to a dusty coma around the comet and a pristine blue ice surface to the comet, which is rich in magnesium silicate. As the comet moves away from the sun and cools, the coma refreezes, taking the dust with it, making the comet appear red again. It's kind of awesome that more than 3 years after Rosetta ended its mission, we're still making new discoveries with its data. We look forward to seeing what more this mission has to offer. And just a reminder, all missions continue to deliver information with their data afterwards. It's really the challenge of getting the missions out there so we can get the data, because it takes years and years and years and tons of scientists to look through everything. And that rounds out our show for today. Thank you for watching. I am Susie Murph, and I am producer of these. The Daily Space is written by Dr. Pamela Gay and is brought to you by the Planetary Science Institute, a 501c3 dedicated to exploring the solar system and beyond. If you like what you see here and you would like to support us, visit us over at patreon.com/CosmoQuestX. And now I will switch over, pull up the chat, and I do believe Dr. Pamela is in the chat with us. Let me check and see. I think Dr. Pamela is in chat with us, so if you have questions, go ahead and post them in there with the purple star, and you should be able to see. I'll try to step up and reach out and read those. Sorry, I'm looking at the list of people who are in the chat. So welcome everybody if you're here in the chat. Once again, if you have a question, put the purple star in front of it. I will try to find it and read it, and we will see if we get an answer. And there's Dr. Pamela. She's Star Strider in the chat, so you can see her. And Frank's Chemist, no, you didn't interrupt. I was happy to say thank you for the subscription. No, we're supposed to interrupt. I'm supposed to say thank you when that happens. No, it's really great. Appreciate it. All right, let's see. Do we have any questions? Space is so big. according to Haney's Vorwerp. Shoot, darn it! The chat jumps before I can finish reading the question. Space is so big, how are all those mergers happening? Sorry about that, Hanny. Yes, so how are all these mergers happening when space is so big and things are so far apart? That's a very good question. And Michael T. Meyer says he thinks that a lot of these mergers are from binary star systems, which would make sense. If they're already close together, then they're more likely to run into each other. Dr. Pamela says the mergers occur because the stars either form together or in super dense places like globular clusters. And that makes sense. We used to tease Fraser over on Astronomy Cast because he used to say globular clusters because he's Canadian. So I think of that every time I see globular clusters. RefSmat says defocusing images of Betelgeuse is necessary for estimates of its varying brightness because it is so bright it saturates your pixels. That makes sense. When you're dealing with digital photography, which is what we're doing now, you can do a lot more with it, but it also can overwhelm your system a little when you're looking at something super bright. Like I said, I'm the producer. I'm not the scientist, but I learn a lot from osmosis and proximity. So I will try to answer. And anything Dr. Pamela says overrides anything I say, just so you know. Broken Symmetry says, it's hard to stay focused. Squirrel. Yeah, I have a dog barking in the background. Squirrel. I'm reading to see if I see questions. Sorry, I should try to talk more while I'm reading questions. And Dr. Pamela is multitasking, so it may take a few moments for her to answer back, but we're working on it. So Haney's Vorwerp says, how far away are stars in globular clusters? Is it less from here than to Alpha Centauri? That's a good question. I don't know how far away some of these globular clusters are. I would think that that's farther. Proxima Centauri is the closest star to us. I don't know about the rest. Dr. Pamela says there can be solar system size separations between things in globular clusters. That's pretty big. And yes, Jake does have opinions. Whenever anybody is outside doing anything anywhere, Jake has opinions. At some point he may pop back in here and I might be able to show him to you. He's cute. But yeah, today was, a lot of talking about how space is weirder than we thought and that stars bump into each other a little bit more often than we think. So that was pretty interesting. Oh, Bridenstine is talking about NASA's budget, according to AstroWise. Yes, apparently the proposed NASA budget came out yesterday, so there was some talk about that. We watched the Solar Orbiter launch last night, and they were mentioning that to the side. So I'm sure there will be a lot of commentary about that coming out this week. Everybody's got to have some time to take a look at it and see what showed up. And now remember, this is just a proposed budget. It has not yet gone through, Congress. And it will not survive intact the way it is through Congress. It just never does. So, Larry says, about the Hubble Deep Field Image, is the rest of the sky has more than that? Does the rest of the sky have more than that? That's a good question. So, the NASA Deep Field Image. I'm guessing there's a new one that is out. I did not see it, but I have not checked my press releases this morning. I just hopped on and started reading a script that Dr. Pamela wrote. I will be reading it later because I was late today. So, if there is another Hubble Deep Field image that is out there that has a tremendous amount of stuff in it, I think what that means is space has a lot of stuff in it. Space is big. But the stuff is all really far away from each other. Dr. Pamela says she knows nothing about a new deep field image. So you'll have to let us know which image that is, Larry, and we can find out for you. If you've got a link or something, send it to us in like Discord or Slack, and we'll take a look. DPI 209 says, I think I recall hearing, and please correct me if I got that wrong, that there are more multiple star systems than single ones. I believe they're finding that it is more common to have like binary star systems than single ones, but that's me saying I think I remember hearing that. Dr. Pamela would let us know. Oh, and the Hubble Deep Field image, she says, was the emptiest piece of sky, so they were essentially taking an image between all of the nearby things to look at the background. Okay, that's cool. So Frecht Chemist asks, does every galaxy have a star? Can stars exist outside of galaxies? And how do we define a galaxy? Those are good questions, because we use those terms all the time, but sometimes it's good to go back and remember exactly what they mean. So DPI 209 says stars can get flung out of their galaxy and drift alone in the empty darkness of space. Thankfully, stars bring their own fuel and their own light with them, so they can. Stars can exist outside galaxies, Starstrider says, and galaxies must have stars, and galaxies are defined by overall mass, composition of matter and dark matter, and formation. And Frecht Chemist says, I realize I don't even know what a star is. A hot ball of gas? A solid? Who knows? I do believe it is a hot ball of burning plasma of a certain size and temperature that has convection going on in it, and it is reducing things down to primary elements in the middle, and yeah. A star is a giant gravitationally held together ball of gas that is big enough to burn hydrogen through fusion, Dr. Pamela says. So I was getting there. I was getting close. But yeah, basically it's big enough and massive enough and has enough fuel in it that it is on fire in plasma and all that stuff. And you can have things that are real close to that size and not technically on fire. Those are brown giants. Those are big. Frecht Chemist says, but how do I know it's gravitationally pulled together if it's out in a vacuum? It's a good question. Stuff has mass. Mass exerts gravity. Gravity holds stuff together. A lot of times it's pulled into a sphere, and it's pulling things towards it. Not a scientist, so I'm reading the answers in the chat. Hanny's Vorwerk asks, would it be a good use of telescope time to take a deep field picture that corresponds to the coolest and the hottest parts of the cosmic microwave background? I think so. I think that would be pretty cool. They probably have taken those pictures because I know they're paying a lot of attention to the cosmic microwave background. And Dr. Pamela says, yes, that has been done, Hanny. I don't think the results were exciting. And I know that they had a lot of fun because they did eventually come up with what the background color of space is, which is a cosmic mocha, like a coffee that you've put a lot of cream in, is what they've come up with, like the color of light in the universe. I don't know that that's necessarily related, but I knew that bit of information. A star is a huge naturally occurring thermonuclear bomb that takes between a few million and a few trillion years to go off, according to Larry Weird. Yeah, I could see that would work. Yeah, cosmic latte. I think I said mocha. It's lighter than that. It's latte. Cosmic Latte is the color that they named it. Which I think is a very cool color, but a little boring to put on your walls. Trivia tidbit from DPI 209. The magnets in the Large Hadron Collider are cooled to 1.5 Kelvin, which is cooler than outer space. Yes, this is true. They cool it down colder than space, because space, not all of space, is at absolute zero. A lot of space has some heat in it. And Larry Weird says, but I would rather have a mocha myself. Me too. And I'm going to have one when we finish streaming. I'm going to go and make myself, well, mocha or a latte or something. I'm going to go make myself something. Something with protein shake in it. That's what I'm going to make. Coffee with my protein shake. Let's see what everybody's saying. I'm realizing I'm not in my camera straight today. I apologize. I've moved it around a couple of times trying to catch Jake, and I've got to pay attention. Am I missing anybody's questions? Larry's apartment is almost painted Cosmic Latte. There you go. Haney's Warp says, I thought space was 2.7 K or something like that. 2.7 Kelvin. I don't know what the average temperature of background space is. That was a good question. If Dr. Pamela knows. The cosmic microwave background is, though, Haney. It's 2.7 degrees Kelvin. Or 2.7 Kelvin. I don't think you say degrees when you're talking Kelvin. The temperature of space on average is from the cosmic microwave background, but it can vary. So, good thought, Haney. You were right. That is roughly the estimated average. And Paranor says, yes, space is hard and the universe wants to kill us, no matter how pretty it is. It is very pretty, but it is trying to kill us. Let's see. Any other questions out there? It's kind of a short news day. I'm sure we will have lots more stuff coming up this week because things will get rolling this week. If nothing else, they'll talk about the NASA budget. And I believe stickers are on sale over at Redbubble. If they are not still on sale, we at least still have them. So you should go over and visit our CosmoQuest Redbubble store. Check out the links in the chat. And we have super cool stickers about how deadly the universe is over there. Or you can get a t-shirt or a tote bag. And all of that goes to support our work here on CosmoQuest. And bring you things like the Daily Space, which is what we're doing right now. Yes, there is a sticker that says the universe is trying to kill you. Literally trying to kill you. And hi, everybody coming into the chat. Better late than never. So does anybody have any other questions while we're doing this? Yes, the dog you are hearing is my trusty second in command, Jake, who has strong opinions about streaming and who is letting me know my son just got home from school. Come here, Jake. Come here. Let's see if I can show him to you. Jake, say hi. Good boy. There we go. I don't have a second dog cam yet, so I have to just occasionally move mine. So you can see Jake. Yeah, he's my co-pilot back there. He lets me know whenever anybody's doing anything nearby. And now he's sitting next to me chewing a blanket because he's adorable. Veronica, thank you so much for saying my hair looks good. Yes, it has purple streaks in it now, which is really hard to point when the camera goes a different way. It's not merchandise on Streamlabs. It is on Redbubble, Carbolo1. So if you look up in the chat a little bit, we have a link to our Redbubble store. And no, I don't let Jake take command of the wheel. He's second in command in name only. He's actually more of my security officer. Yeah, when I turn, you can see the ombre. Yeah. Yeah, I went back and I got purple streaks in it. So it's lighter pink at the top, medium pink, and purple. So, yeah, I'm doing the full Twilight Sparkle here. Jake's a red shirt. Careful, Jake. No, he's the head of security. He's not just any red shirt. He's the head. So, since Picard is my captain, he's Next Generation, Jake would technically be a gold shirt. He would be Worf. So, he is no red shirt. But thank you, Henny, for saying my hair looks great. And there's Jake again. Yeah. Real vampires don't sparkle. No, I'm not a vampire. I'm Twilight Sparkle, a pony. Thank you very much. That's My Little Pony. Not a Twilight vampire. Jeez. Jake sings the blues. Yep. Teach him Klingon. I think he already speaks Klingon a little bit. Or at least he certainly wants to fight all the time. No. He just defends me. He's my buddy. He has strong opinions. He's Mama's dog, so he's got to stay over here and let me know when dangerous people like the FedEx guy show up or an Amazon package is delivered. You know, dangerous things like that. Very good knowledge of the uniform colors. JB McCool, I totally have a geek card. And I have had it since I was 7 and went to see the original Star Wars in the movie theater. Thank you very much. I have always been a geek. Trillian H2O says, taking all versions of Star Trek into account, Starfleet is in desperate need of a mental health program. Yes. Yes, it is. Very much so. They need a lot of mental health problems. I have started to watch the new show Picard, but we only got 2 episodes in before we were actually already letting go of CBS All Access. But no spoilers, but it looks pretty good. I was pleased with the premise of the show, and I was pleased with the way they started out and the amount of storytelling they were doing, and I was very pleased with the theme song. So, go check it out. Yes, Deanna Troi can't be everywhere. I wanted to be Deanna Troi so badly. I have been her for Halloween, and I have been Beverly Crusher for Halloween. Yes, I've been all of that. So, and my background is psychology, so I very much identified with Deanna Troi when I was in college, for sure. That's when I watched Next Generation. That was over my college years, so yeah. Yeah, I was very happy with the first episode, too, of Picard. I think it's good. So, I look forward to trying to figure out a way to watch it now that we got rid of CBS All Access. I don't know why we started a show and then got rid of it, but we'll find it. And Catherine Janeway, she did a good job. I didn't watch as much of Voyager as I did the others, because by then I was out of school and married and kids and, you know. And it came on channels I didn't always have. That was harder. But Picard, Next Generation, that was my favorite. I mean, when I was a kid growing up, I saw the original on reruns, but Next Generation was the one I would sit up at night to watch, for sure. All right. At this point, we have totally devolved into just talking about Star Trek and goofy stuff, and we are not talking science news anymore. So what I'm going to do is I'm going to go ahead and let you all go for today. And I'm going to get started getting all of this stuff up on our website. I take this script, turn it into a podcast, I will turn it into a blog post, and I will send it out to all of our Patreon followers. And it'll be up later today on dailyspace.org. So if you want to read what I read today and see all the links and see the pictures and stuff, you can visit that in a little while. And I will download this video, edit it, and go put it over on YouTube. So it will last longer than just the week it's here on Twitch. The worst Star Trek beat the best original Lost in Space. Oh gosh, yes. I mean, the cheesiest episode of Star Trek definitely beats the original Lost in Space. All right, everybody. Thank you so much for being with us today. Feel free to tune in tomorrow. Dr. Pamela is going to be fairly busy this week, so you may see me pop up a couple of times this week, or Annie pop in a few more times this week than usual, because, of course, Dr. Pamela gets sent work by our bosses over at Planetary Science Institute sometimes and has to do paperwork and things. So the rest of us are ready to hop on and stream. So keep your eyes out, but somebody will be here with you tomorrow to put more science in your brain. Once again, we're a product of the Planetary Science Institute, a 501c3 nonprofit, and if you would like to support what we do and help us bring you the science, support us over at patreon.com/CosmoQuestX. Thank you so much, and I will talk to y'all again in a few days. Bye-bye.